Hello, welcome back once again, dear students. So, in the current chapter of heat transfer, so far we have been discussing about conduction. But there are so many examples of conduction in our daily life. For examples, during winter, to keep our body warm, we all wear woolen clothes, that is sweater, muffler, etc. Because reason is very clear, you all know. That is the woolen cloth. Inside woolen cloth, there are so many porous gaps, and these gaps contain so many airs. Okay, so much airs. And during winter, the temperature of the outside is much less than that of the temperature of our inside our body. So the air inside our body or inside the porous gap of the woolen cloth is much greater than that of the air of the outside. And since air is a bad conductor of heat, so it doesn't let this that is heat, that is the warm heat, to escape from the body to outside, and also it doesn't let the cold heat to enter from the outside to inside our body. And in this way our body remains warm and gives us a pleasant feeling. So another example is in the handle of kettle to serve the tea or any liquid. Generally it is wrapped or wound with cane or any bad conductors. Since bad conductor heat cannot conduct through it so rapidly, so it doesn't burn our hands so easily, then it becomes very easier to serve any hot tea or any liquid like that. Again, during winter or summer, it is very pleasant to stay inside the home made of the hay, that is hut, HUT hut, because it is just like woolen cloths. Inside hay there are so many porous gaps which contains airs, and during summer the temperature of the outside is very hot and humid, but the temperature of inside the home is slightly less. So during summer, since air is bad conductor of heat, it doesn't let to escape the cold air from home to outside, and also at the same time it doesn't allow the hot air to enter inside the house. Again, in the winter, the temperature of the air outside the home is slightly less, whereas the temperature inside the house is slightly warm. So again, it doesn't allow to enter the cold air from outside to the house, and again it doesn't let escape the hot air from inside the home to outside, and remains the entire home slightly warm. So just like conduction, there are so many examples of convection also. Convection means in which heat transfer due to the shipment or the displacement of the molecules. The molecules itself carry the heat. So one is the land and the sea bridge. Okay, so what is land and sea bridge? So during daytime, we all know that land gets heated faster than that of water bodies. Why? Since water is the bad conductor of heat, and specific heat capacity of water is much more, isn't it? So it needs a greater amount of heat to rise same amount of temperature. So if you want to rise the same amount of temperature, land, that is which is made up of dust material, sand, stones, all these materials, their specific heat capacity very less. It means to rise same amount of temperature, they requires very less heat. That's why they generally get heated very quickly as compared to water bodies. And also the absorbing power is also very high. So due to all this in the daytime, because of the heat of the sun, due to the sunlight, they becomes heated very fast. And since as soon as they become very fast, the air adjacent to land becomes warm. As soon as they become warm, they expand and they become light, and they rise in the above. And since the air which are adjacent to water bodies, they are not as warm, as heated as the land by sunlight. So then there is a vacuum is created. So to fill that vacuum out of land, the cold air from the sea, okay, comes to the land, goes to the land and fills the blank. Fill that vacuums. So since this bridge is coming from sea to the land, since it started journey from sea, so that's why it is called sea bridge. Bridge means pleasant air, pleasant flow of air or pleasant wind. Okay. So the cold air which travels from sea to land, it is called sea bridge, and its intensity becomes maximum at evening. Okay. Now moves to land bridge. So it's very clear, the bridge which travels from land to sea, it is land bridge. So let's see what happens. As soon as sunset, that is during evening or night, since we all know that a body which gets heated faster becomes colder faster by rejecting heat. So since at the daytime land become warmer or hot by absorbing sunlight, so at the evening time or night time by rejecting the heat, it will become cold faster, isn't it? but the water body is just ascend to the just above the sea level, still become hot since it is a bad conductor of heat. Since it doesn't get heated faster, so it cannot become cold faster, isn't it? So the air above the land now becomes cold, whereas the air just above the sea surface becomes hot. So now the air just above the sea surface, since it is hot, so it becomes light, becoming warming. So now it moves, it rises in the upward direction, then creates a vacuum here, blanks. So to fill that blanks or vacuum, the cold air from the land, okay, moves to the sea, and this is cold air, and this is called land breeze. So just guess when its intensity can become maximum, can be maximum? At the dawn. At the dawn, the intensity of the land breeze is maximum. Clear? Now moves on to next topic, very important topic. That is, it is based on radiation. That is black body, then perfectly black body. Now what do you mean by black body? Now black body, though it seems that it is colored in black, no, a black body doesn't mean it appears black in color. A body, isn't it, when any radiant heat is incident on it, if it absorbs, completely absorbs the entire radiation of all wavelengths, whatever bit of wavelength, if it absorbs, completely absorbs the incident radiation, then it is called black body. And why it is perfectly black body? If it doesn't reflect and transmit any stress, small stress of light, it means whatever with the light will incident on it or hit, any incident heat will absorb it. If it absorbs 100% of incident radiation, okay, then in that case it is called perfectly black body. But in practice, it is extremely hard. It is hard to come by a perfect black body. Okay. Although a lamp black and a platinum black almost behaves like a black body, because a lamp black can absorb up to 5% of incident heat of radiant heat, whereas a platinum black can absorb up to 98% of incident radiant heat. Okay. Now since why it is called black body? Generally it is a black body, black in color. Since I am talking about in terms of radiation, incident radiation, since it absorbs all amount of radiations, all the wavelengths, since radiation contains wavelengths, so whatever be the wavelengths associated with it, it absorbs all sort of radiation, doesn't reflect or transmit any radiation. So basically most of the time it appears black. That's why it is the reason behind the body appears black, though it is not mandatory. It is not black. This is the first definition of black body. But this is in terms of absorption of the incident radiation. This is incident radiated heat. But if at a particular temperature, if we hit any body at a very higher temperature, then a body, if it emits all sorts of radiation, then it is also called black body. Clear? So that's why it doesn't mean that a black body always remain or appear black in color. It may be white also. Okay. Perfect example is sun. Okay. So it means when any radiation is incident on it, any heat radiation, then if it absorbs all radiation, completely all radiation, then it is called a black body in that case. Or if we hit any body at very high temperature, then if it emits all sorts of radiation, then it is also called a black body. Okay. Now since sun, as I said, a black body doesn't mean, it is not mandatory that a black body will appear black always. Due to the definition of the second definition, since inside sun, isn't it, it is an immense amount of temperature, and since sun emits all sorts of radiations of almost all wavelengths, radiation of all wavelengths are generally emitted from the sun. So that's why the sun can also be considered as a black body. Okay. Now the energy which is emitted, the energy emitted from any black body, isn't it? The radiant energy from a black body is generally greater than that of radiant energy from any body, isn't it? The energy through heat or through light which is emitted through a black body or any perfectly black body is greater than that of and radiant energy from any source of body. So that's why a perfect black body, the radiation from a perfect black body is also called a perfect black radiation. Okay, a black body radiation. Okay. So now we will just discuss about a black body which is generally designed by Ferry, and after his name it is called Ferry's black body. Clear? Now this is generally a double walled as you can see, double wall hollow metal sphere, whose inside is generally made black by polishing with lamp black. Okay, and outside is made glossy or shiny by nickel, isn't it? By varnishing or through through nickel. Okay, its inside is made by polishing through lamp black, and outside is made shiny, extremely shiny or bright white. Okay, polishing through nickel, and inside is made absolutely vacuum. So so what is the significance in this case? So in this case, the heat loss, the heat loss or the radiant loss due to radiation, due to convection and the conduction, inside is made convection, inside is made absolutely, inside is purely vacuum, there is no space, no air inside it. So what happens in this case? The heat loss due to the convection and the conduction is generally stopped, it ceases, and outside is bright, glossy. So in this case, the heat loss due to radiation is stopped, isn't it? So now what the inside here, you can see there is a very small aperture hole, isn't it, which is made for incident radiation, so that light can enter through it. And inside, isn't it, you can see very straight line, just straight, exactly in front of it, isn't it, a sharp edge, isn't it, a sharp edge, is it not, isn't it, a sharp edge, isn't it, a middle edge is generally, the inside is designed directly from which the light or the heat is incident through the person exactly at its front. It is designed through a sharp edge. But so that if it is not sharp edge, as soon as if the light is incident, it has opportunity, it can just reflect back to the outside. Clear? So that the incident radiation cannot escape out through reflection through it. So that's why this edge or this surface is generally made through a very sharp edge. So what happens, you can see, once light is incident through it, then it suffers multiple reflection. Once it gets to this body, and through all these multiple expression, it cannot escape out because it has no space to escape out. That's why this surface is made a very sharp middle edge. If it was plain, light will enter and then returns back. So in this way, through multiple deflection through this, after some time the entire radiation or heat is generally absorbed, and it looks like, isn't it, and it looks like a black body. And this is first made by the Ferry. So after his name, it is called Ferry's black body. As I said, in practice it is difficult, it is absolutely impossible to combine a perfect black body. So in this way, perfect black body